Question 5. A pendulum swings back and forth in a circular arc between x and y. The pendulum bob is always in equilibrium, only in equilibrium at x and y, in equilibrium as it passes through the central position, and never in equilibrium. Well, D is correct because at every point of this arc there is some acceleration taking place. You may think that at the equilibrium point it is in equilibrium, and it is true. In the horizontal direction there is no acceleration, so in the horizontal direction there is no net force. The acceleration is zero, but you do get an acceleration, the centripetal acceleration inward at that point, so there is a net force acting on that in the towards the center, and so there is never a time when it is in equilibrium. So D is the correct answer there. Question 6. We have a block of mass m is moving at constant velocity v along a frictionless surface. It's important, frictionless surface that is a height h above the ground. Which expression gives the work necessary to maintain the constant velocity? Now remember, a formula for constant velocity for work is this over here. This is our formula, and notice it's force times the distance, or the force in the direction of that distance. Now because this is not going at a constant velocity, because this is going at a constant velocity, there is no external force that is required to be acting on this, and therefore 0 is my correct answer. D is the correct answer for this one. Going on to question 7. Which of the following is an elastic collision? Now, I think you'll be able to see this straight away. Two railway trucks collide and link together. No, that is inelastic. Remember this idea that elastic, this is when the kinetic energy and the momentum is conserved in a collision. Two railway trucks collide and they do not link together. Whenever you're dealing with things like railway trucks, there is always going to be a loss in kinetic energy, because there's always a lot of energy that is lost in the form of heat and friction and so forth. But question C is correct. Two molecules collide and each change direction. So we're having two particles coming in, they are colliding with each other, and then they are shooting off in different directions. That would be an elastic collision. It's actually one of our points for a ideal gas, that all collisions are elastic, and this would be because here they form a bond, so they don't bounce off each other. Question 8. A car moves at constant speed around a horizontal circular track. So we've got it going around a track at a constant speed. The resultant force of the car is always equal to, now the force is always inwards, because it's going at a constant speed. The only acceleration is a change in direction. That's always towards the center, so it won't be a forward force. That's not correct. The sideways force between the tires and the track, that's what's keeping this car changing direction, so B is the correct answer. The weight of the car, that's not going to do anything, and it's not 0, so B is the correct answer in that case.